Okay, this is the second part of the lecture number 1 on week 12. It's the problem number 3. Unfortunately, I could not join this particular video clip, which is about 15 minutes, to the part 1, and therefore lecture 1, week 12 appears in two pieces, part 1 and part 2. So I want to create a design table for this problem, which was done a week ago, but I parameterized that. It's an assembly, but I parameterized it. In other words, I said, create these things in the tree so that I can go to those values, those parameters, change it, and the whole thing resizes, etc., etc. Okay. I don't think when I parameterized it, I had the wedge material or the material and the name. All I had were these numbers, and I changed it if I remember correctly. Right. So what I want to do is create a design table, and here's my table. I've already created that, and I want to be able to go to these particular rows and the whole thing, the whole assembly resizes, and the assembly constraints, by the way, assembly constraints hold. In other words, when you move things apart and you update, it should go back to that configuration in the middle. Okay, so let's go ahead and start our product file. Product. And of course, immediately I save this thing. So file, save management, save as. I have on my desktop. I have let me see. I have on my desktop a folder called problem 3 right there, and already in it there is that Excel spreadsheet, by the way. Okay, so let me start making the wedge, the inside piece first. So I will go and insert a new part in there, and I'm going to call this thing the wedge. Right click properties, wedge, and wedge. Okay, okay, let's go make it. So on that vertical plane, I will make this something that looks like that gray piece. So here's the way I'm going to do that. You do it any way you want. Okay, and then use a line going from here up, and then going down. Oops, and then going down to that point. Okay, good. So let's dimension these, and I'm going to use these nominal dimensions. So radius is 1.5, and that angle is 60 degrees. So let me dimension these things. This radius is going to be 1.5. This saves you a great deal of headache later on, so that you don't do things that cannot be made actually. And this is going to be 60 degrees. All right, good. Exit and path. That's fine. Now, because in my tree, I have the material for the two different parts being different, I have to apply a dummy material here. So where's that apply material? Right there. I'm going to apply dummy material. I'll call it aluminum, but just remember, do not apply it to this this line, okay? Apply it to that. In other words, apply it to the part. This really, look, there's two gears here. So if you really want a part, there we are. This is it. Do not apply it there, because otherwise it will not work. And then you say, okay. By the way, the difference is that if you have one difference is that you apply it there, that aluminum will appear as a separate branch way down here, right below this double gear and the white sheet. Good. So let's go out here, insert our next piece, insert a new part in there. I'm going to call it the box. properties. I'm pretty sure we call that thing the box, right? Box, yeah. Wedge and the box, except that the wedge, just remember that when it comes to creating a parameter, it has to be exactly like that. Otherwise, you have to otherwise you have to do some manual association. So I'm going to call this thing box and box. Let's make it. So on that same plane, I will sketch. There are different ways of doing this thing. If this is bothering you, I'm going to hide that and make a centered rectangle or square and dimension it like that. And these nominal ones are h. This is h, right? H is 5. Okay, so I'm going to make this thing. That's almost 5. That's okay. And then I do exactly the same thing that I did before in the inside. And dimension appropriately. So this is going to be R, but it's going to be 1.5, 1.5. And this angle is going to be 60 degrees. I mean, later on, obviously, these are changing according to the entries of the design table. Okay, good. Exit and pad it. Oh, sorry, not pad it. Yeah, pad it. That's right. Pad it. There we go. The other guy is in here. The other guy is in hiding. If you want to see it, for example, it's right there. As a matter of fact, I can bring it in the front. Where is that? Hide and show. Okay, good. In fact, I can change the color. I can change the color here, but I'm not going to do that right now because when you change the color, the dimension in the sketch, the color changes. It's going to be hard to see them. Now we have to apply dummy material and again apply material on this part, but not to this line, to the actual part. Actual part is a single gear, as you can see. And some dummy material, I'll call it brass, it doesn't matter, I could have used aluminum. Okay, fine. Good. So we go all the way to the top, all the way to the top, and save this thing. And then we're going to start our parameters. I want to show you something, and that is the different approaches of doing that. For example, because this is supposed to fit in there, I can take the radius, for example, the radius of this yellow piece and say it's equal to the radius of the gray piece. So this is equal to that. And then say that guy, the radius of the gray piece is equal to R. Same way, I can say the angle of this yellow piece is equal to the angle of this gray piece, and then the angle of the gray piece equal to beta. That's one way of doing it. The other way is just doing it the long way, maybe the safest way, is to take all of these and equal to all of these dimensions and directly equate them with the parameters that we're going to create. Okay? So let's see now. These are the parameters. We need 3 length and 1 angle. And incidentally, I'm going to be doing these 4 columns manually. Okay, these I'm going to create and as parameters, but these I'm going to do manually. So let's go ahead and do that. Where is this? You go here. Make sure you're at the very top, at the top level. Do not create parameters at the part level when you're doing an assembly type problem. Okay, unless, yeah. So we're going to click on f of x. Length, one of them is going to be h. And I believe h was 5, nominal value 5. Another one is going to be r, nominal value 1.5. Another one is uh, padded length. Let me see for a second here. It's called L, right? And value, nominal value, well, we can use 1. And then we have an angle, change this thing to angle, click on new parameter, call it beta, and the nominal value is 60. Apply. Good. Now notice that these parameters have been created here. Now we have to create our equations or relation. Now it's easier if I move these things apart because right now they're going to be on top of each other. So let me translate this thing in the Z direction, right there, a little bit more. And then we say, okay, click on f of x, click on the product, all the dimensions that you want to appear. So I'm going to select this, add a formula equal to h. This guy, add the formula. You know what? Notice that, by the way, notice that these things are all appearing. So maybe if it's easier for me if I click on the box, so only the stuff for the box appears, okay? And in fact, if you want, you can even hide this. You see, you can even hide this. These are all dimensions for the box. Maybe easier to do it like this. You select this, add a formula. This is happening because I translated them and I did the original sketch on the same plane at the same location. That's where we're all tangled up. So also H. This is R, add a formula equal to R. This is add a formula equal to beta. And the padded length is that guy, 0.787. For the box, you can see add a formula equal to L. Good. So I took care of the stuff for the box. So I'm going to click on the wedge, and these are dimensions for the wedge, okay? So I select this, add a formula equal to R. This is 0.787 for the wedge, so add a formula equal to L. And finally, this is the angle for the wedge, add a formula equal to beta. And I'm pretty sure we have taken care of all the stuff for our part. So let me update these things. Okay, where's the other guy? The other guy's in hiding because I hid it right there. Let's check these things to make sure we did not make a gross mistake here. So for example, if I go and change the R, let's take it to 0.5. Update. I'm pretty sure, okay, this fits there. Good, good. Now, do not forget to, later on, do not forget to impose the assembly here. It's very important. So what I'm going to do is, these are the equations that I created, all right? And I did it the long way. So you click on the design table. It says, okay, get it. I have on my desktop, I have problem 3, folder called problem 3, right there. And in it, there is a spreadsheet which has that information that I showed you right there, this thing. Now, obviously, it's not going to know what to do with the first 4 columns. So yes, it pops up, and notice that it didn't know what to do with the first 4. Now, let's first of all, let's check this thing, make sure this is working, okay? Obviously, the material is not going to be properly changed, and the name is not going to be changed. But if I go, for example, to this second row and say apply, okay, and update, notice that they resized, okay? Again, go to the tree, go to the tree design table, don't do a new one, go to the tree, next one, Okay, update, there. Notice that that angle was 90 degrees, so it turns into something like that. Anyway, let's go back here. Get the first one. It's easier for me to see what I'm doing with that. Update. This is the first one. Good. Now, if you go to the design table, you notice that if you click on the association tab, it says, hey, I don't know what to do with these. And notice that your tree, in your tree, the product, the name of these things are not what they're supposed to be. They're supposed to be these. And the material should be, I mean, basically these properties. So let's go ahead and do the following. So when it says wedge serial number, okay, associate, click on the wedge, see that, wedge. Go find the material that says associated this, name, not material, name, part number, right there. Associate this with the serial number. So associate, and notice that as soon as I did that, it changed right there, 1, 2, 3. Used to be wedge, right? Wedge material, scroll down, find material right there. And notice that as soon as I do that, let me see now, this aluminum should change into whatever I had on the table. Associate, right there, gold. The box serial number, why don't you click on the box so that the stuff on the box appears in this list, and then box serial number is going to be part number. Scroll down, part number. As soon as you do that, this becomes AAA, there. And finally, material, scroll down and get the material for the box, which is right here, associate, and this becomes whatever we had there. I could predominant material brass, but it turned into silver. Now, if you go to this tree, you can see that it's appearing the way I want it. And in fact, let's check it out. If we go, for example, to the second row, notice that immediately the name changed to 456 for the wedge and BBB for the box, and the material changed to silver for the box, for the wedge, and what is that? Brass for the wedge. If you go to the last row, again, the materials change, steel and iron, as I expected, and so apply, okay, and update. Now, do not forget to apply constraints. So let me go back to my original configuration. That was easiest for me to work with. Okay, so first of all, we want to put assembly constraints. So we go to assembly design, fix that, anchor that, and now coincidence, for example, between this face and this face, and coincidence between this edge and that edge. When I say update, you get the impression that it works. Oh, actually, let me undo that. Actually, that last one was wrong. I meant to select that edge. Delete this. Try it again. This edge and right? That edge. And update. You get the impression that this is working fine. But let me show you something. Suppose I take this and rotate it about that. And say, okay, update, it goes like this. So there's more to it. And one way, for example, is say coincidence between, we can say this edge and that edge, or this point and this point. So let me do the point. This point and that point. Update. There we are. Now, if regardless of what I do here, all kinds of crazy rotations and translations here, all kind of crazy things, when I update, they should go back to where they belong. Okay, and that took care of the second part of lecture 1. Good luck. And remember, There are 4 variations of these problems. Parameterize a part, parameterize an assembly, design table for a part, design table for an assembly, and you're responsible for all of them on the final exam. You don't know which one you're going to be getting, okay? So you should be prepared to do any one of them. See you on Friday, Thursday, and I'm going to be doing a review by going through a sample test from a few years ago, okay? Good luck.